Dear students, in our last two videos, I showed you how to switch between the S domain and T domain using MATLAB commands. Now, let's talk about another important topic, how to do partial fraction in MATLAB. Normally, doing this by hand takes a lot of time, but with MATLAB we can do it much faster. So let's dive into the video where I will demonstrate how to do partial fractions quickly using MATLAB. Okay. So here you can see this is the partial fraction, here you can see this is the rational fraction, and this is their partial fraction from. Basically these are the common type of partial fractions where we are used to solve problem. So here you can see, so a by x minus 1 plus b by x minus b. So for this rational fraction we use this type of. Okay, so this is basically we are doing by using pen and paper. Okay, now let's consider one equation. Consider a polynomial. Here you can see this is the numerator portion and this is the denominator portion, and bm s to the power m plus up to b naught. Similarly in denominator, here you can see this is the polynomial. So here you can see bi and ai the coefficient of s to the power I in the numerator and denominator respectively. Okay, so here you can see bm minus r are the coefficient of the s term. Okay, so the above polynomial can be simplified by using the partial fraction expansion, that is the tedious problem. So here we use the MATLAB command to simplify the polynomial into the partial fraction. So the command in the MATLAB for partial fraction conversion is, we call it is residue. Okay, so here you can see this is the command. So basically we write first, we have to write the num equal to bm minus 1 up to b naught. So this is nothing but the coefficient of the numerator polynomial. Similarly we have to represent the denominator portion. So here we consider that variable the den equal to an minus 1 dot dot up to a naught. So this is the coefficient of the denominator polynomial. First you have to define the coefficient of the numerator polynomial as well as the denominator polynomial. Then you have to write this command so you can get the partial fraction value. So here you can see r comma p comma k equal to, the command is residue bracket number comma number means num comma dem. Okay, so you have to remember r is the column vector that contains residue, p is the column vector that contains the pole of the system, and k is the row vector which contains the direct term. So just remember these three lines, then you can easily convert to the partial fraction. Okay, look, let's take one example. So here you can see this is the partial fraction of the p. Here if we consider this from that r1 divided by s minus p1, r2 divided by s minus p2 up to this one and ks. Okay, so if all the variables in the column vector p are the same, so we can write this way, like r1 divided by s minus p plus r2 s minus p whole square plus up to s minus p whole to the power n plus k. Okay, let's take one example and try to solve by using the MATLAB. So here we take this portion, that s plus 1 divided by s cube plus 6s square plus 12s plus s. So first you have to write the numerator and you have to define the denominator. So here you can see in the numerator, so coefficient of s is 1 and here is 1. And similarly in the denominator, here s cube coefficient is 1, s square coefficient is 6, sh coefficient is 12, and s to the power 0 coefficient is 8. Then you have to write this code command, that is r comma p comma k equal to residue comma num comma dem. Then you can get this output where r is the residue. So here you can see 1 minus 1 and p is the pole, minus 2 minus 2 minus 3. So here you can see all the poles are the same, and k equal to, here nothing means k equal to 0. So you have to represent like this. So here you can see, so if it is in this form, means in this cube form, so you already know it will be a by something plus b by whole square up to s cube. Okay, so here you can see, so first portion here r, here you can see it is 0, then second is the 1, here you can put this is 1, and third here is a -1, so just put this value. And for the pole, here you can see s -2, so s of -2, it will be the s plus 2, similarly s plus 2 whole square and s plus 3 whole square, sorry 2 whole square. Okay, let's directly go to the MATLAB. Okay, so first you have to define the num, so it will be the 1 and 1 coefficient. Then I am defining denominator portion, and its coefficients are 1, 6, 12 and 8. And next we have to write the command, that is r, p, k equal to residue num, den. Okay, very easy, just run this program. Okay, there is 2 bracket. So here you can see you get, so r equal to 0, 1, -1, p equal to -2, -2, -2 and k is 0. Okay, now coming to next slide. So here if you want to convert the opposite, means to obtain the polynomial of the numerator and the denominator, we can use the same residue command as the follows. So just in the left hand side you have to write num and den, and the right hand side you have to write the residue rpk. Okay, so we are taking the previous example, same example. So here you can see we write r, p and k. So r as a column vector, so here we have to write this way. Here p also the column vector, so you have to write -2, -2 this way, and k, then you have to put this command, that is num, den equal to residue rpk. Okay, so here so r will be 0, so here you can see 0, 1, -1, p will be -2 semicolon -2, as this is the column vector -2, then k equal to nothing, you can write also. Then write the command, that is the num, den residue, and write r, p, k. Close the bracket and run the program. So here you can get the value of numerator, that is 1, 0 means s plus 1, and denominator portion, that is the s cube plus 6s plus 12s plus 8. Okay, next we are taking one more example. So here you can see now the equation is 2s, numerator equation is 2s cube plus 5s square plus 3s plus 6, and for the denominator here you can see s cube plus 6s square plus 11s plus 6. So here you can see, so numerator the coefficients are 2, 5, 3 and 6, and denominator 1, 6, 11 and 6. Okay, directly we are going to in the MATLAB, so just write the num. So numerator coefficients are 2, then 5, then 3, then 6, then denominator coefficients are 1, 6, 11, 6. Just then write the command, that is the r, p, k residue and num comma den. Okay, just run this program. So here you can see, so r is the -6 -4 3 and p is the -3 -2 -k -1 and the value of k is 2. So from this, if you closely monitor these poles are not the repetitive poles. Okay, so finally, so here you can see the partial fraction of this function will be the -6. Here you can see -6 by s plus 3. Here pole is the s plus 3. Then r2, that is -4. Here you can see -4 divided by s minus 2, s minus of -2, then -1 divided by s plus 2, and this is the 2. Similarly, we will convert the reverse portion, means we have to represent num and den by using the r, p and k value. Okay, so just we are taking that so just represent, so r will be -6 semicolon -4 semicolon 3 and p is -3 semicolon -2 semicolon -1, k is only 2. So just write the value, just write the command, that is num comma den, so equal to residue r comma p comma k. Okay, just run this program. You can easily get the okay. So here you can see, now you can get the number, numerator coefficients are 2, 5, 3 and 6, and next is the 1, 6, 11 and 6. Now if you convert this number or den as a s term, so you have to remember one more extra command. So here you can see, so the command is print system print sys in bracket num comma den and this value of the s. So if you write this command, then the number and so the ratio between the numerator and denominator in terms of the ratio of the polynomial in the s form. Okay, so just I am writing this command. So just you have to write print system num comma den comma s. So here you can see, so you will get in s form, means 2s cube plus 5s square plus 3s plus 6. If you don't use this command, so you will get in this term, so you will only get the coefficient. But if you use this command, so then you can use in this form. Okay, so in this video you learn how to convert the partial fraction. So you have to remember only one thing, that is the residue, and you have to remember that r, p, k value. So here r is the column vector that contains the residue, p is the column vector that contains the pole, and k is the row vector that contains the direct term. So you have to remember this one comment, that is the residue. And for the inverse conversion, just you have to change the here. So you have the here you have to put number num comma den, and here you have to put rpk. And one more comment, so if you present your numerator and denominator in s form, so you have to remember this command, that is the print sys comma num comma den comma s. Then the numerator and denominator will be represented in this form. So just remember these 2 and 3 command, so you can easily convert the partial fraction in the MATLAB. So in the next video we take two more example and try to convert. Initially we try to convert in the partial fraction, then we take its Laplace and try to find the Laplace transform as well as the inverse transform. Thank you.